Alright, this is the second video going over the Chapter 1 test. So let's just get right into it. Number 1 is talking about a problem in which they give you the mean of 15. They give you the standard deviation. They say that we're approximately symmetrical. They give the IQR and some other information. So what is the value of the median? Well, all we really need to know is what the mean is and the fact that these data are symmetrical. If that's true, we know that the mean is approximately equal to the median, and so we can answer A by saying 15 because the data are symmetrical. That's all you really had to say for that. Other people, said, well, let's look at halfway between the minimum and maximum, or halfway between Q1 and Q3, even though they didn't give you that. That's not all necessary, it's all okay, but really this is all we needed to say here. Okay, here's where confusion began for some people. We were given 3 data points in the distribution, 15, 12, and 24. We were asked if we were to remove just one of these data points, what would essentially happen to the standard deviation? And so we need to remember that standard deviation measures average deviation or distance from the mean. Okay? So what we can see is that 15 is 0 from the mean. 12 is 3 from the mean, and 24 is 9 from the mean. So if we were to remove the 15, we would be removing a point which is 0 from the mean. Meaning, the other points left over would be on average further from the mean. We're sort of removing a 0 from the average of the deviations. Okay, that's going to pull the mean, that's going to increase the standard deviation because the rest of the data are on average further away than that 15, which is right on the mean. All right? For the same reason, if we remove the point which is further from the mean, the other points left over are on average closer to the mean. And so that would mean that removing 24 would decrease the standard deviation. All right? And notice, it doesn't matter if the 24 is above the mean or below the mean, or if the 12 is above the mean or below the mean. It's how far it is from the mean, above or below. Okay? So if we think about the same reasoning for number 2 of this part, which data point, if removed, would have the least impact? Well, it's got to be the 12, because the 12 is 3 from the mean. The current standard deviation is 3. So the 12 is exactly 1 standard deviation from the mean. Okay? Removing that value will have the least impact on the standard deviation. Because if you think about it, we're removing a point that's 3 from the mean. The other points are on average about 3 from the mean as well. Okay? Now, it is important to understand that the standard deviation would change because the mean would change. All right? But it would change by the least amount if we removed this one value. Okay? All right. B said if we have the original data set, one of the points is a 21, we remove it, or not, sorry, we don't remove it. We change it from a 21 to a 35. Would the value of the IQR change? Well, IQR is resistant to outliers. That's true, and perhaps 35 is an outlier. But what's more important is that this 21 that we're changing is bigger than Q3. It's outside of the IQR. So, if I have this box plot, I don't know if it looks like that exactly, the 21 is out here. If we take this point and pull it way out here, well, all it's going to do is pull that whisker bigger. The IQR does not change at all. So in order to get full credit for this, you had to really say that 21 was above Q3. Okay, and increasing values above Q3 are not going to change the positions of Q1 and Q3, and thus the IQR will not change. All right, so let's move on. This next one was about the three rivers, and we're measuring the concentration of aldrin, this pesticide. So we're measuring it at 20 randomly selected locations in each river. We're given these box plots. We're asked to compare the distributions. Okay, so it's important to compare, to actually make statements that related X, Y, and Z. And in order to get full credit for this, you had to compare and also look at shape, center, and spread. Okay, so shape, basically you're going to say X is right skewed, Y is the most symmetrical, and Z is left skewed. Center is a little easy to actually make a comparison statement. In general, X's concentrations were higher than Y's, which were higher than Z's. And also looking at how the variability or the spread, X's was the most spread out, then Y, and then Z. Okay, so you had to compare those three things. And you had to compare, not just list a bunch of attributes of each river and then move on from there. Okay, then you had to make a stem plot. There's the stem plot. Some of you put like the decimal points. That's not necessary. Some of you split the stems. It's okay. You don't have to do that. This is the way you would typically see a stem plot for this. Okay? And so the next question says, look at the stem plot and look at the box plot. What's something you can see from this that you can't see from the box plot? So if we look at this, there's a gap here in the sixes. If you look at the box plot for river X, 6 is like in the heart of the IQR. So there's no indication from the box plot that there's a gap there. Okay, we cannot tell that from the box plot. We can clearly see that from the stem plot. All right, that was one thing that you could have said. You could have also said that the shape of this is, kind of bimodal. Okay, they're kind of two areas of concentration in the 4s and 5s and the 7s and 8s. Okay, so those are the two things that you could have said there. Some people said things that you could tell in both. Some people just referred to that the actual data are shown in the stem plot and they're not shown in the box plot. That's true, but that's not specific enough about what the actual data show. Okay, so in order to get full credit for that question, you sort of had to say one of these two things. All right, and then finally, interpreting the standard deviation, sort of a standard thing that you need to be able to do. Standard deviation measures the average deviation from the mean. So you needed to just put that in context, and you needed to mention the number 1.72. So on average, each concentration measurement differed from the mean measurement by about 1.72 parts per million. Okay? Note, it's not correct to say that the majority of the values were within 1.72 of the mean. We saw that that's not necessarily true. We need to talk specifically about what standard deviation measures to get full credit for this. All right. Last question was about two additives added to gasoline. We're trying to see how it affects the gas mileage. So we were given some summary data, and the first thing was show if they're outliers in additive A. And this is just your straightforward, not even thinking criterion that you have to follow, that you just need to know. Okay, so there's really no excuse to not knowing that criterion. Some people still messed it up, but basically you can look at this, you can pause it, whatever. We determined that those three values are outliers. All right, based off of that, we made a modified box plot. Okay, and so important things to note here is that we plot those three values as individual points, and we pull in the sort of bar for the maximum into the next non-outlier. And if you look at the data, the next non-outlier is -2. Okay? Box plot B, or distribution B, didn't have any outliers, so we just made that a normal box plot. In order to get full credit, you had to distinguish between A and B. It's kind of a silly thing to lose a point on by not labeling which was A and which was B. Okay, so now we have the box plots, and now we have to answer some questions about the distributions. Now, a lot of times the way these questions go is they have you create a graph, and then you're going to answer some questions, and they may not ask about the graph specifically, but the graph will help you answer the questions. Okay, so let's look at this. It says that there are two ways that we can gauge the effectiveness of the additive. One way is to look at the proportion of cars that have increased gas mileage, okay, and the other is to look at the average increase in gas mileage, or change in gas mileage, I guess. So part one said, which should we use if we're looking at trying to increase in the highest proportion of cars? Okay, so increasing gas mileage, that would mean when the difference was greater than 0. So if I look at the box plot right here, that's sort of the cutoff. Everything over to the right of that 0 is an increase in gas mileage. Okay, so if we look at additive A, we can see that Q3 is above 0. Okay, which means that more than 75% of cars using additive A increase gas mileage. Okay, in additive B, well, Q1 is actually less than 0 and the median is greater than 0. That means between 50 and 75% of cars increase gas mileage. Thus, A is better. Okay, and you can look at that explanation right there or on the online version of this solution set. So A is better if the goal is to increase gas mileage in more cars, in a higher proportion of cars. Okay, now the next question said, which would you recommend if the goal is to have the highest mean in gas mileage? Highest mean increase? Well, basically we need to compare the means of A and B. We weren't given the means. And I can see that, yes, A's median is bigger than B's. However, B is very, very skewed right. Okay, it's so skewed right that these higher values are going to pull the mean further to the right than A's. Okay, and so B is going to have a higher mean increase. And so the answer to that question is B. And you had to mention the skewed nature of the data in order to do that. So this was a really good question. That wasn't overly complicated, but the difference between those who got it and those who didn't, or those who got it understood what the question was asking. Those who didn't understand, and their answers sort of indicated that, and the answers just didn't make any sense. So always make sure you read the question carefully and think about what it's asking. Okay? All right, so I hope this was helpful. I'll give you a due date, or we'll give you a due date on those revisions. But make this a learning experience for you so that in future tests you don't make these sort of mistakes, that you get better at answering these sort of questions.